Hello folks, and welcome back to my mainframe channel. This is Moshix, and today we're going to be doing some VSAM work. I've been asked a couple of times already in the comments and in direct emails if I could do a tutorial on VSAM, and I've been delaying it for a while because to do it properly you really need to go into programming, and you also needed to go into catalog management, because catalog management and VSAM kind of go hand in hand. Also because an MVS catalog is a VSAM object on its own. So now that I have released a couple of weeks ago, or maybe a month ago, I've released early September or mid-September, I released a tutorial video on how to deal with catalogs. I feel now is a good time to get a little deeper into the whole VSAM topic. Also, my previous video, the one I released a couple of days ago on how to install kicks on MVS 3.8, it kind of shows how heavily VSAM is involved with kicks, either the kicks that we use on MVS 3.8, which is the one written with 2 Ks and 1 C, kicks as in kicking, and also of course very extensively used in kicks as written with 2 Cs, CICS, the IBM product. So both use very extensively VSAM, and funny enough, even when people say, well, but nowadays people use really DB2 on the mainframe, or even Oracle or something like that, or no, we use IMS, DC, Deal 1. Well, all those databases, they use VSAM as the underlying file system. So the way we have to think of VSAM is it's not really a database, although it can be used, of course, as a database. It's not really a file type. It's really an access method. What I mean by that is that IBM supplies with MVS, and of course OS 390 and ZOS supplies a set of APIs and a set of basic macros, even at the assembler level, which you use then to relate to VSAM. We also have other access methods, obviously, in MVS. We have QSAM, which is the queued sequential access method we use, for instance, when we want to write and read from an assembler program, from a data set. There's also BSAM, there's other access methods, and there also used to be something called ISAM, which actually I liked a lot and used extensively, which was an indexed sequential access method, which would let you define a data set with a key, which was then the index, and then you could access later on the data by providing the key, and very simple to use. Then VSAM came along in 1971, I want to say. Let me see here what wiki says. VSAM, yeah, it was released, when was that done? In the 70s. I think it was 71 or 72, and the reason VSAM stands for Virtual Sequential Access Method, and the reason why it's called virtual is that it works obviously with virtual memory. And in the early 70s, IBM was so excited that they had introduced virtual memory and demand memory and paging as part of MVS, that they started calling everything virtual. So VTAM is also virtual telecommunications access method. Everything is called virtual. They were so excited about it that they managed to do it, even though other computer systems already had virtual memory way before. I'm thinking here, for instance, of the Atlas project in the UK, which I think was the first computer using virtual memory. I think they were using pages of either 1 kilobyte or 2 kilobytes. But anyway, IBM introduced virtual memory and MVS, and everything started to be called virtual. Now VSAM is therefore, it's an access method, which means it's a series of APIs which you can use to store data and retrieve data, and then retrieve the data in an intelligent fashion. And as such, VSAM kind of was meant to replace all the previous XFSs, because with VSAM you can either write, and I think I saw something here in this page. Yeah, you can use it to access a sequential file, read from it, and write to it. You can do indexed operation, which kind of replaces ISAM, and that's called the key sequential dataset organization. And then you can have linear VSAM organization, which is almost like files in the Linux or Unix sense. And then you have relative VSAM, where you would have to do your own management of the records inside the VSAM. Now, VSAM, of course, is also aware of records, such as we have with everything in MVS or in the mainframe, and also VSAM obviously needs to cooperate with the catalog on the volumes on which it recites. So the way I like to think of VSAM, it's almost like as if it was a file system, because you can use it for so many different things that I like to think of it as a file system. So very often what I do in my production MVS machines is I have 1 or 2 volumes which I commit totally to VSAM, and so I have a catalog, a user catalog on those volumes, and then VSAM owns the whole volume, and I will not have any non-VSAM data sets on that volume. So let's, by the way, VSAM itself is very fast. I think it's probably the fastest file system access method that I have seen anywhere. It uses binary trees very extensively, and so sometimes that means that sometimes VSAM needs to be reorganized. If you have a lot of inserts and a lot of deletes from a VSAM file, you eventually want to reorganize so you can rebalance the binary tree. And for me personally, this has always been a very, very interesting topic: how to store data very efficiently on disk, and how to retrieve it, hashing, keys, all these topics I've been studying since the age of, I think, 10. I did my first hashing algorithm when I was 10 or 11. And you spend a lot of time coming up with ways to avoid collisions in the hash, which obviously is a topic relating to cryptography. Anyway, but let's go here and see how we're going to use VSAM here today. By the way, everything that's in this tutorial, I will put the link under this video in the description below the video you're watching right now. But I created a GitHub repository, as I often do for my videos, and there is 3 basic JCL jobs here. 1 to create a VSAM, 1 to delete it, and 1 to copy data into it. So I'll make the link available under this video. Please do get the repository so you can follow all the steps I'm doing in this video. So first of all, I fired up a MVS instance here. In this case, it's MVS 3.8. By the way, I've made the fonts bigger. I hope that all of you are able to see the screen here just fine. This is all 16 size fonts, so you should be fine. And again, I have this, whatever I just showed you on the GitHub repository. This is where we're creating a GitHub repository from this directory here on my Linux virtual machine on top of my Intel NUC. If you want to say create, or the VSAM create, then this is the job that creates it. By the way, one more thing: whenever you work with my mainframe GitHub repositories, you want to go and get. I will also link below this video my MVS general repository. Why am I mentioning that? Because there is a Vim control file there. This one, which I suggest if you work a lot with mainframe stuff on your computer, you add everything that's in here to your Vim repository, to your Vim control file, so that you have proper syntax in your JCL. So if I do VSAM create, you will see that I have very nice syntax highlighting, and also I have this red bar which tells me where column 80 is, so that I never write into column 80, which of course in JCL means continuation to the next line. So you may want to get this repository, but we're going to look at everything that we have on the screen here in this pane here in this window. We're also going to have on the mainframe, because this is where I got it from. And how did I get it? Very simple. I did FTP localhost to my MVS instance running here, and I have HERC01, the standard password, and then I went to HERC01 test cntl, and this is where these members are from. Remember that FTP, you have FTP available in your MVS 3.8 as delivered by TK4. How do we start it? How do we stop it? We stop it with FTPD. We'll stop it. If you want to, I'm stopping first because it was already running. But if you want to start it, you say start FTPD server port SRV port equals. I usually use 2100, and that's it. And then you can connect to it. So let me stop it here because I don't need it anymore. FTPD. Okay, down. Let me also. Okay, MF1 is not active. Okay, so everything is perfect here. Let's log in. HERC01. Okay. Why is the font? Okay, better. So VSAM, let's start by looking at how VSAM looks on the volumes. I'm going to be using POP001 here, obviously free to use other volumes. So this is POP001 as it looks right now. There is only one dataset that's interesting here right now, which you probably don't have in your own installation, which is a sequential file, sequential dataset with record length 23, and make block length whatever is most sensible to your device. I was lazy here and did 230. It's probably not the best block size. By the way, in my Moshix repository, if you go to the MVS repository, this one, which as I said I will link, there's a block size a Go language program which is already compiled for Linux, which will show you for any record length and for any device type. And we have the device types here, starting from 2311 all the way to 3390s and even 9345s. It will calculate the best block size. So I suggest you use this. Again, it's in MVS here in my GitHub repository called MVS. I'll link to both repository, the VSAM one, as well as the MVS repository. Back here, so I have this data set called HERC01 moshix.indd in dataset, and I mentioned this one because it's usually work with you probably most use with record lengths of 80 bytes. Here I use 23 for a very particular reason, because I created here a simple database of employees, Moshix, and some other people here. So I'm going to make this. So we have a little bit different data. Okay, so I created a little database here. Maybe we add one more. 7. I would call it YouTube $7,000 salary, and then it's 17. We are in October, and I think today is the 28th, if I'm not mistaken. Let's see here. Yep. So that's it. We just created a little database here. It's make this uppercase with UC, so we don't have funny stuff in the database. And there is obviously here, I don't see any VSAM dataset. VSAM are always of organization VS in this column here. So now let's see, how do we create a VSAM? In this tutorial, we're going to create a VSAM database. We're going to show how to populate it with data, and we're also going to show how to delete it. And in a later tutorial, maybe in the next few days, I'll show a little COBOL program, if I get to it, to read and write from the VSAM database. Now, a lot of people will immediately start sending comments and emails saying, hey, the MVT COBOL compiler we have in TK4 with our MVS 3.8 is not able to read and write VSAM because MVT, the predecessor of MVS, didn't have VSAM. Well, that's true, but Jay Mosley, my hero, Mosley, VSAM COBOL, he actually wrote an assembler routine which interfaces with COBOL so that our MVT compiler can indeed read and write from VSAM databases. So that's what I'm going to be using in the next tutorial, so we can read the database, the employee database we just looked at. Our TK4 is actually much better than a lot of people think. I mean, you have TCP/IP, we can send emails from MVS, we have FTP. I'm working on a telnet server and client for our MVS. So there's quite a lot of stuff in there already. All right, so how do we create a VSAM dataset? Let's go to the editor and let's look at this. So this, obviously, anytime you are interfacing with VSAM and want to organize your VSAM stuff, we're always talking about ID camps. That's a standard utility IBM provides to work with VSAM, and make this a little more beautiful here. Sorry for the mess. I know we got into it. And now IDCAMS has its own language, which is the one you see here. Okay, that's how you talk to IDCAMS, and then IDCAMS goes and uses the VSAM access method. IDCAMS is written in assembler to do stuff on the volumes on the disks. So this is a standard job card here. This is there's two cards here. HERC01 VS for that's how I call it here. Create VSAM class A. I put it in H so we can go have a look at it in the spool. Message level 1. I use here user and password. You don't have to do it if you submit it from within TSO, but maybe some people want to do it from the Linux or Windows machines through the card reader, so I just put it in there with the standard password. If you change obviously your user or the password, then you have to supply it here. And then we have the IDCAMS card, sysprint, which you need, I think you do need to specify for IDCAMS to work, and then sysin, and then we have the in-stream cards for IDCAMS. So what I do here is, first of all, I delete, because I'm going to create this database. So first I want to delete it so that I don't, because otherwise I'm going to get an error message saying, hey, you're trying to create but already exists. So to avoid that, I delete it, set the condition code back to 0 so that even if it doesn't exist, it will not report then, usually with a 12 condition code that you try to delete something that doesn't exist. So either it deletes it, or if it's not there, it will fail, but set the condition code back to 0. And then I define a database. So now in VSAM, the database is called a cluster. Okay, and the cluster is organized in control intervals, which is like data containers within the database, and you can keep adding control intervals to a cluster if you're running out of space. And so you need to provide obviously what is the name. It's going to be called HERG01 Moshix employee. I'm just using one E here, just because I want to keep it simple. And then we say it's an index database, so that's a key sequential database. It's going to be on volume POP001. I want it there. And then sometimes you need to provide a card here, / POP1, and then a Volsera to connect this one with a volume, especially if you're doing catalog stuff. Sometimes you need to provide it, but here in this case it's not needed. I'm gonna make it 15 tracks big, and I'm gonna share field 1 and 3. Those need to be unique, so that's a hard requirement. The database we just looked at, the employee database, and then the record size is going to be 23 bytes. Span is how it's organized. Let's avoid that for a second, and then we make it 2 keys starting from byte 0, and then we need to split it in the data and the index. So, and we need to provide names for that. So the convention usually is, you don't have to do it this way, is that you give the same name that you have here in the cluster, and then attach data for the data itself and index for the index, so that you can all keep it tidy and together, and you don't start deleting stuff by mistake or not backing up properly. And that's it. And so this is a very typical VSAM job. We're going to run it now, and keep an eye here on the IOs per second. And okay, done. A few hundred IOs, because obviously it needs to go and do a lot of work on the disks to set it up. And then I'm getting here the notify from TSO that it ran job 34, which we should see here. Yep, job 34 with maximum condition code 0. I'm already happy. Let's go to the 3.8 spool viewer, and let's delete all the stuff we don't need. And this is 34, job 34. Let's look what it says. And this is the output from a typical VSAM job. Okay, so condition code 0, we already know that. And this is now IDC, that's VSAM. So always remember that IDC is VSAM. ID cams basically talking to us. So ID cam saying that entry Moshix not found, and that of course will give us a return code of 8. And that's why, by the way, we set here the maximum condition code back to 0, so that we don't, if you had, for instance, a conditional JCL, it wouldn't bump out here. So, so it's not deleted because it doesn't exist, but we set it back to 0 here, and then we have our language which we provided here. So it did allocate our cluster, and it did data allocation, index allocation work, function complete, ID camps processing complete, maximum condition code is 0. So now that is done, and if I open yet another window here and go to POP001, you'll see that my cluster, which is comprised of my data here, employee data and the employee index, has been created. And you see here the organization is VS for VSAM, and it always shows full occupation, the data set always will look full from the outside, because that's how VSAM keeps it. So you don't want to, there's nothing to worry about that. Block size is automatically decided by VSAM itself, and so we don't have to provide the block size because VSAM does all that for us. There's no logical record length, because from the outside you don't see the records. It's organized by VSAM itself inside its binary tree. So if you want to have some information about it, again, it's a block length of 4096 bytes. VSAM record format is U. U is almost like a stream of bytes, so that's how it looks from the outside, but then inside it's VSAM organized. This is of course a little weird, created here, expires in 2000. That's, I think, that's a year 2K problem, but it will not disturb us. And and so this is our data, and then index. The index data set looks a little different. Indexes obviously are much smaller, so that's why VSAM keeps the block length smaller. And then again, you have a record format U, stream of bytes, as it looks from the outside, because it's managed by VSAM. So so that's how we run this thing. Now, what do we do if we want to delete it? If we want to delete it, then we have a del VSAM. We would use this one. Again, same thing. Delete VSAM cluster. We use ID cams, and then here we say delete HERG01 Moshix employee. Since it's a VSAM, I don't have to say anything else. I could also use ID cams to delete any data set on any disk, and then I would just say none VSAM or no VSAM. Yeah, no VSAM. But since it is VSAM, I don't need to write that. And obviously here I don't set the delete, the maximum condition code to 0 with set max CC equals 0, because I want to know. So let's delete it. Let's execute this job. Let's it's DE for delete. Execute it. Condition code 00. And let's go what it says here. Condition code 0. And then ID cams will tell us it deleted. So when you delete the cluster, it will delete automatically both the data and the index. So it deletes the whole cluster, and so that's how we delete this data set, this VSAM cluster. And so now that we deleted it, let's go here and look at our volume pub001, and obviously the cluster is gone. There's only our little sequential file here with our data, which we want to get into the VSAM database. So let's go and do that. So this should be here. Let's recreate it now that we've deleted it. And this should just run without problems. Yeah, so it was created. We don't need to go and check. Let's just trust VSAM that it is there. Now, how do we get the data from the sequential data set, the employee, into a real database and have it indexed by the employee ID or employee number? So let's go and do that. I have another job here, which is called repro data. Why do I call it repro? Because the ID cams language for moving data from one place to the other, or to reorganize, it's called repro, reproduce, or I don't know what reproduction. I don't know what it stands for, but so this is what we do. We need to provide the where from and where to. So I call it INDD. That's why this data set is called HERG01 Moshix INDD. And then we need to an out DD, which is our cluster. And we don't need to say data and index, because VSAM knows what to do with it. VSAM is aware that this is a key sequential data set, so it's indexed with a key. And so when we then say repro from in file INDD to out file out DD, then VSAM knows exactly what to do. Before we run it, let's go look at the data again for a second. And of course, yeah, we also know that the cluster is here. So you see, this is going to be one key, and then this is another key. So because we had two keys specified, but if we use this key, anytime we supply a key of 01, then VSAM will retrieve record, this record here. Oops. Oh, what did I do here? Okay. Anytime I provide 01 as the key, then VSAM is going to retrieve me this whole record here. Okay. So we want to get all this data, all of this, into the VSAM database and have it automatically indexed by this column and by this column. Okay, so let's go do this with the repro job that's in your GitHub. So repro from INDD, from our sequential data set to the database. Let's run this. Job 37, condition code 0. So here it is. Let's see what IDCAMS tells us. IDCAMS system services, and number of records processed was 7. Function completed, highest condition code was 0. So now we got in 7 records into our database. Now let's deal a little bit with certain error conditions. One thing that you may remember is that when we created it, we said that the keys need to be unique. Okay, so what happens if we have a key collision or a hash collision, as I call it? So let's go look at the database on the sequential source, and let's just recreate this slightly different. Okay, what will happen if we try to insert 2 records with different with same keys? Okay, so we go and run this job, repro. Very interesting. Submit it. Error condition code 12. Okay, let's go check what it says. Action error. Duplicate record. So we have several duplicate records, and so therefore it did not process any of it. So this is very interesting. Okay, if I had any unique records, then it would not insert them. Okay, so this is transactional in a way that, you know, it has VSAM scans and tries things before it actually doesn't, and so it's not like it's processing 1 record that's unique and then it finds 6 that are non-unique, and then so 1 is inserted. It will actually say none has been processed, and that's the way you want it to be, so that you have a consistent database. Because you don't want to do a partial import and then you don't know what was imported and what wasn't. So that's why VSAM is really much more than just an access method. It's a database management system, really, and that's why everything else is based off of VSAM. DB2, Oracle, any kind of sophisticated database management system will use VSAM. The catalog itself uses VSAM. So this is what we have in here, and obviously now to look at the records inside the database, we would have to write a software to extract them, or we could of course extract them by doing repro the other way around, right? Nothing prohibits from creating, like saying out in file. We could say in file out dd, even though it's terribly named. Out dd, and then we would have out file new sequential, and then here we would then lid this card and make it new sec, and then dd dsn, we'll call it, I don't know, Moshik's new disposition new catalog. And then the DCB, would have to obviously provide the DCB, what is the size of it, etc., etc. So you could move it out of the database, obviously, into another sequential data set. But obviously, if you want to do anything more sophisticated than that, extract the data, change it, put it back into VSAM, you need to have a software to do it, either PL1 or Assembler or COBOL, and that is what I'm going to do in the next tutorial on this topic. I don't know when I'm going to do it, but I'm going to do it because it's going to be interesting to use Jay Mosley's VSAM access for the MVT COBOL compiler. So this is it. I hope you're going to download the repository and play with it a little bit, because having VSAM experience is kind of important in the mainframe world. It is pervasive, it's everywhere, and this is just the simplest way to define and work with VSAM at the very basic level. Let me go and delete it so that okay, I don't have anything lying around. So this is it. I hope you learned something here about VSAM today. If you like this video, please press on the thumbs up button on the below this video. If you're not subscribed to the Moshix Mainframe channel, please do subscribe so you can get notifications of future videos. And have a great day. Thank you very much. Goodbye.